A quiet dawn over the atoll. The ocean appears calm, almost peaceful. But beneath this surface lies a force capable of changing humanity's understanding of war and nature forever. The summer of 1946. After the end of World War II, the world enters a new era, the era of nuclear weapons. Military leaders and scientists prepare for an experiment designed to answer a critical question. What happens when an atomic explosion occurs not in the air, but underwater? Dozens of ships are positioned across the lagoon. Battleships, cruisers, submarines, all turned into targets. There are no crews aboard. Only instruments, sensors, and cameras ready to capture every detail of the coming catastrophe. On the decks, final preparations are underway. Technicians check the equipment. Scientists verify calculations. There is no room for error. Everything must be recorded with absolute precision. Beneath the surface, at depth, the device is secured. Encased in a metal structure and surrounded by water, it waits in complete silence as the countdown begins. The command echoes through loudspeakers. 10, 9, 8. Faces grow tense. Even those at a safe distance understand they are about to witness a force beyond control. 3, 2, 1. For a fraction of a second, everything stands still. And then, a flash. An intense burst of light erupts underwater, instantly shattering the silence. Pressure builds at an unimaginable rate, and the ocean itself seems to explode from within. A massive column of water surges upward, rising hundreds of meters into the sky. It carries with it tons of water, vapor, sand, and debris. A Vishal dome forms, a mushroom-like cloud, shaped not by fire, but by the ocean itself. The shockwave expands in all directions. The ships anchored in the lagoon stand no chance. Steel groans, hulls fracture, massive vessels are thrown aside like toys. Some ships capsize, others sink within moments. Those that remain afloat suffer devastating damage. The water near the epicenter appears to boil. Enormous masses rise and collapse back into the lagoon, generating secondary waves that amplify the destruction. But the explosion is only the beginning. In the towering column, radioactive particles are carried into the air. They mix with vapor, forming an invisible threat. Minutes later, a phenomenon known as black rain begins, contaminated droplets falling back into the lagoon. The surviving ships become deadly hazards. Their surfaces are coated with radioactive residue. Even brief exposure can be dangerous. Teams in protective suits are sent in. They measure radiation levels. Geiger counters crackle. Readings surge beyond safe limits. Scientists record everything: the force of the shockwave, the behavior of water, the extent of destruction, the spread of contamination. These data will shape future military strategies. But beyond the numbers lies something deeper, an understanding of the scale of destruction. The ocean, once seen as a symbol of life and natural power, becomes a conduit for devastation. Water does not shield, it amplifies the blast. The ships, once symbols of naval strength, now drift, broken and abandoned. Some slowly disappear beneath the surface, leaving only oil slicks and debris. Over time, the lagoon grows quiet again. The waves settle, the cloud begins to dissipate, but the consequences remain. Radioactive contamination lingers, affecting water, metal, and sand for years to come. This test becomes a turning point. It demonstrates that nuclear weapons can devastate not only cities, but entire environments.
humanity gains new knowledge and new responsibility. The sun sinks below the horizon. Silence returns to the lagoon, but it is no longer the same silence as before.
Liked the video? Subscribe to the channel and hit the like button.